Okay. I think you all have a basic idea what is what probability is, right? What is the probability? So in day-to-day life, we do not regularly use the word probability, but we use some similar words. I have this much percentage of confidence in saying that today's match is going to win. Likewise, we are saying about the probability, but we are not using the word probability, but we all are familiar with the concept of probability in our day-to-day life, right? So what is the probability? In general, probability is defined as the likelihood or the chance of something happening, right? And we are using this probability theory in variety of fields, like in sports, including insurance, investments, weather forecasting, and also in our day-to-day life also, we are using this probability without knowing the word of probability, right? So actually in generally, so here in this slide, I'm going to teach you the general concept of the probability. So normally the probability is in between 0 and 1, right? Where the 0 indicates the impossibility and 1 indicates the certainty, right? And the higher the probability of an event, the more likely it is that the event will occur. So when the probability increase close to 1, there is more likely to that event will occur. So actually, when you are learning in second year and third year, we are learning about the inference in statistics, making decisions in statistics. So in making decisions, so in inferential statistics, the probability is the base, right? So it is very important to learn the concept of the probability. So these are some basic concepts or the basic notations we are using in probability. So you are familiar with these words, but in Sinhala, I guess. So the definition is given here. What is the probability? Probability is the measure of likelihood that an event will occur in random experiment. So there are some keywords there: event and random experiment. So what is an event and what is a random experiment? What is a random experiment? So before learning about the definition, you should know these concepts. So what is a random experiment? A random experiment is one in which we know the set of all possible outcomes but cannot predict which one will occur at any given time. So in random experiment, if we do an experiment, we know what are the outcomes would be, right? But we don't know, or we cannot predict which one is going to occur in the given time, right? For example, it's given here, toss in a fair coin. So we know that either head or tail will come. So they are called outcomes. The outcome is the result of a single trial of a probability experiment. When someone tosses a coin, then we get two outcomes, head and tail. We know what are the outcomes as head and tail, but we know which outcome will occur in the given time. So those kind of experiments are called random experiments. So when casting an unbiased die, again we know what are the outcomes. The outcomes would be 1, 2, up to 6, right? Since it's an unbiased die, they have equal chance of all the numbers have equal chances. They have the equal chance of selecting, right? So we know what are the outcomes, but we can't predict what would be the outcome at any given time. And also the drawing a card from a pack of 52 cards. Again, we know the outcomes, right? There are 4 yes in a card pack there are 42 cards and 4 sections, hearts, diamonds, spades, and clubs, right? So in each there are 13 cards. So we know the outcome when drawing one card. We know all the outcomes, but we don't know, or we can't predict which card is going to be selected at any given time. So those are an examples for random experiment, right? Okay. So another useful thing is sample space, right? Sample space. What is a sample space? A sample space is a set of all possible outcomes of a random experiment, right? So now we know what is a random experiment and we know about the outcomes. Now the sample space gives you the set of all possible outcomes of a random experiment. For an example, when we flip a coin, the outcomes would be head and tail. So all the outcomes means head and tail. So it is the sample of space of that random experiment. And also when we rolling a die, again we have 6 outcomes, and the list of 6 outcomes is the sample space of that random experiment, right? So we can write the sample space by listing all possible outcomes, or else we can create a tree diagram, right? You know what is a tree diagram? I guess රුක්සටහන නේද? මට හිතෙන්නේ එහෙමයි. මට මතක එහෙමයි. In Sinhala, right? Okay. For an example, find the sample space. I know these are very basic concepts, but as the base of this course, I want to teach you those things, right? So find the sample space of the experiment from simultaneously flipping a coin and rolling a die. So here, the random experiment is we have to flip a coin at the same time rolling a die, right? So for the coin, there are 2 possible results as head and tail. And for rolling a die, there are 6 possible results as 1 to 6, right? Then all the possible results when flipping coin and rolling a die simultaneously can be written as head and 1, head and 2, head and 3, head and 4, up to head and 6, and then tail and 1 up to tail and 6, right? Altogether, how many outcomes are there? 1, 2, 3, 4, 5, 6, and 12, right? There are 12 outcomes. So the list of all 12 outcomes is the sample space of that random experiment, right? So rather than listing the sample space, I think it's the tree diagram gives you a better understanding. Okay, so the experiment is flipping a coin as well, and also simultaneously a die. So we can indicate, or we can represent the sample space using this tree diagram. It's easy to obtain the sample space using the tree diagram, right? So you know these things. So just to recall the memory in your A level, right? Okay. Find the sample space for the sex of 3 children in a family using a tree diagram. Use B for boy and G for girl, right? So this is another example in tree diagram. So our outcome pertains to sex of one child and second of the next child and the sex of third child. Each of the children will correspond to a branching in a tree, right? So first child should be would be boy or girl, and when given the sex of the first child, what is the sex of the second child? That is the second branch of the tree. First branch is what is the sex of the first child, right? It could be either boy or girl. And the second branch is given the sex of the first child, what is the sex of second child, right? So, and the third branch allocated to the given the sex of the first 2 children, and then what is the sex of the third child. So that's how we are going to get the sample space, right? So this is the first branch, and this is the second branch, this is the third branch. So all the outcomes are indicating here. So the list of all the outcomes are denoted in the sample space, right? Okay. Then another important terminology is event, right? So now we know what is a random experiment and what are the outcomes of a random experiment and how to write or the indicate sample space, right? So the terminology event, it gives us any subset of a sample space associated with an experiment is called as an event, right? So in event, there can be one outcome or there can be more than one outcome, right? So an event with one outcome is called as a simple event, and an event with more than one outcome is called as compound event. And also there is another event called null event. In null event, it have no any outcomes, right? Null. So it's called null event, an event with empty set, right? So when we're rolling a die and get a 6, only one outcome. So it's called a simple event. So it's a subset of the sample space, and there is only one outcome in that event. So it's called a simple event. So when roll a die and get an even number, when we roll a die, we can get 3 even numbers, isn't it? 2, 4, and 6. So there are 3 outcomes, more than one outcome. So it's a subset of the sample space, 3 outcomes out of 6 outcomes, and it is called compound event since it has more than one outcome, right? So it is so altogether any subset of a sample space associated with an experiment is called an event. Okay. So here you are going to learn basic interpretations of probability. Actually, when we are discussing about the probability, we are discussing about 3 types of probabilities: classical probability, experimental or relative frequency probability, and subjective probability, right? So the first one is theoretical, or we say classical probability. So in classical probability, we use sample space to determine the numerical probability that an event will happen. So we use here the sample space to calculate the numerical probability of an event will happen, right? in classical probability, we do not actually perform the experiment to determine the theoretical probability, but the important thing is assumes that all outcomes are equally likely to occur, right? Here it is an important thing. In theoretical probability, we assume that all outcomes are equally likely to occur, right? So what is equally likely to occur? Equal likely occur events means events that have same probability of occurring, right? So if we have a fair coin, then we know it has an equal chance to getting head and tail as 0.5. And also when we roll a die, the numbers 1 to 6 have equal chance of getting selected. So those are called equally likely events, right? So the classical probability of any event can be calculated using this simple equation. The probability is equal to number of outcomes favorable to E divided by total number of outcomes in the sample space. So it's very easy to understand. So let's consider an example. Determine the probability of getting an even number when rolling a die, right? So we are rolling a die. So the event is getting an even number, right? So number of outcome to favorable to E is getting here E is getting even number, right? So we can write the probability of having or getting even number. We want the number of outcome favorable to getting an even number. So there are 3 possible chances: getting 2, getting 4, and getting 6. So there are 3 chances, and it should be divided by total number of outcomes in the sample space. So we know in the sample space there are 6 outcomes. So 3 over 6, it's 0.5. So that is the classical probability of getting an even number when rolling a die. So here we do not do the experiment. We assume all the events are equal likely to happen, and then we use the classical probability equation to calculate the probability, right? In the second example, consider a standard deck of 52 cards. Find the probability of selecting a queen, right? So there are 4 chances of getting the queen: spades, hearts, diamonds, and clubs, right? So there are 4 chances, 4 number of outcomes favorable to getting a queen out of the sample space. The sample space is total number of outcomes in the sample space is 52. So it is 4 over 52, right? So is there any question? So if you have any question, you can raise your hands, right? Or either I will give you chance to ask questions at the end of the lecture, right? Okay. So now we are going to learn another important thing, rounding rule for probability. In this 12th slide, you can see here, and in the example 1, the probability is 0.5, and example 2, 0.07692. So there are so many values there, right? So when we writing the probability, it's better to know the rounding rule for probabilities, right? So probability should be expressed as reduced fractions or rounded to 2 or 3 decimal places. So it's better to write your probability value in 2 or 3 decimal places or a reduced fraction. that would be also okay, right? When the probability of an event is an extremely small decimal, it is permissible to round the decimal to the first non-zero digit after the point. And for an example, here in the first example, you can see, so there are so many decimal places here, so many decimal places. So we have to round it into 2 or 3 decimal places like 0.077. You can also leave this as a reduced fraction as well, right? 1/30. And in example 2, if the probability is a very small decimal, see here 0.0000587. So you can write it as, you can round it to the decimal to the first non-zero digit, right? So 587, you can write it as 0.00006 to the first non-zero digit after the point. Okay, so this is called the rounding rule for probabilities. So when you are writing probabilities, you should have to consider this rounding rule. Okay. Okay, another important thing, you should be very careful when we are using the word and or in probability, right? It's very important to understand the meaning of words and or. So for an example, to find the probability of getting a queen and a heart, right? When you were drawing a single card from a deck, you would be looking for the queen of hearts. Here, the word and means at the same time, right? Simultaneously. Getting a queen and a heart, both events occur simultaneously at the same time. That is the indication of and here, right? And. And the word, if we use word or, it has two meanings actually. For an example, to find the probability of selecting a queen or a heart, when one card is selecting from a deck, right? So we know from a card pack we have 4 queens. And how many hearts? There are 13 cards having the heart, right? So in this case, the queen of hearts would be included in both cases, right? So inside these 4 queens, the heart queen is included. And also in the 13 hearts, the queen is included, right? So when we count it, we are counting it twice. Inside the 4 queens and inside the 13 hearts, right? So we have to reduce 1. So 4 plus 13 minus 1. So there are altogether 16 possibilities. So this case is called inclusive OR, right? And in the second case, to find the probability of getting queen or king. So there are no interception there. So it's called an exclusive event. So there are 4 possibilities of having queens and 4 possibilities of having kings. So there are altogether 8 possibilities. So the thing I want to highlight here is when you use word and or, you have to be very careful and try to understand the thing behind the word and or. Okay. Okay. Can you try these things? Okay, I'll give you 5 minutes. Do this exercise. So I think you all are familiar with this card pack, right? So if you don't know, there are 4 suits actually. The first set is suits of heart, then diamond, spades, and clubs, right? From A, then 2, 3, 4, 5, 6, 7, 8, 9, 10. And then J, the jack, I guess, and queen and king. So for each suit, there are 13 cards, and altogether there are 52 cards, right? In 4 suits. Okay, the first one is getting a jack, right? So how many jacks are there in a card pack? There are 4, right? One is for hearts, then diamond, clubs, and spades. So there are 4. So the probability of getting jack, there are 4 possibilities out of the total outcomes in the sample space is 52. So it's 1 over 13. You can keep it as a fraction, right? And getting 6 of clubs. 6 of clubs. That means getting 6 and a club, right? So there are only one outcome, one card containing number 6 of clubs, right? So it is 1 over 52. And getting a 3 or a diamond, right? 3 or a diamond. So there are 4 possibilities of getting 3 and 13 possibilities of getting diamond. But the diamond 3 is repeating in both cases. So it should be 16 over 52. It is 4 over 30. Right? So it is an inclusive OR. Getting 3 or 6. There are 4 possibilities of getting 3. And there are 4 possibilities of getting 6. So altogether, there are 8 possibilities over 52. So it is 2 over 30. Okay. Could you please explain the third one? Right, okay. Okay. Someone has sent me a message to explain the third one again. Right, okay. Okay. So this is the deck, right? So the third one is asking you, what is the probability of getting 3O diamond, right? 3O diamond. So 3O diamond, right? So when we consider the first event, it is getting 3. So how many possibilities are there? There are 4 possibilities, right? Then the other event is getting a diamond, 3O diamond, right? So in diamond, there are 13 cards. So now can you see the 3, the outcome 3, this one is repeating twice, right? So for the event getting 3, there are 4 possibilities, and getting diamond, there are 13 possibilities. But here the 3 is repeated. Therefore, we have to put it as -1. So altogether, there are 16 16 possibilities of getting 3O diamond. Is that clear now? Right, I think it's clear now. Right? Okay. Okay, then let's move on to the probability rules, right? So there are 4 basic probability rules. The rules are helpful in solving probability problems, in understanding the nature and deciding if your answer to the problems are correct. So they are the basic probability rules. There are some rules you have to learn in future, but these are called the basic ones, right? Basic probability rules. The rule 1, the probability of any event E is a number, either a fraction or decimal, between and including 0 and 1. So I explained it earlier. The probability lies in between 0 and 1, and also the including 0 and 1. 0 and also 1 is included in here. So it denoted by the probability of E is in between the range 0 and 1, including 0 and 1 also, right? So that is the rule 1. So if an event E cannot occur, that is, the event contains no members in the sample space, its probability is 0. So it's the clarification of probability 0. If any event cannot occur, the probability of that event is 0, right? If an event is certain, you are 100% sure. We are saying that in sometimes we are 100% sure that he will do these things and those things, right? So in general, we are saying that, so if an event is certain, the probability of that event is occurring is 1, right? Probability of E is 1. So then the event E is certain to occur. The rule 4, the sum of the probability of all the outcomes in the sample space is 1. That is an important one. The sum of the probabilities of all the outcomes should be equal to the 1, right? Now ඔයගොල්ලෝ ගණන් හදද්දි එහෙම සමහරවිට එකට වැඩි ඔක්කොම එකතු කරපුවාම sample space එකේ තියෙන outcomes එකට වැඩි නම් ඒ කියන්නේ ඔයගොල්ලෝ ගණන් හදලා තියෙනවා වැරදි. Right? So you have to check your answer by using these probability rules. Okay. Okay. Another important concept is complementary events. Complementary events. So these things you have learned in your A levels. I'm recalling them, right? Complementary events. The complement of an event E is the set of outcomes in the sample space that are not included in the outcomes of event E. The complement of E is denoted by E bar, right? So when we're discussing an example, you will get what is the complement. The outcome of an event and the outcomes of the complement make up the entire sample space. The sum of the probability of the event and the probability of its complement will be 1, right? So when a die is rolled, find the complement of getting odd number. So event is getting odd number, right? So the event is getting odd number. We have 3 possibilities, 1, 3, and 5. So the complement is not getting an odd number. So not getting an odd number means we have again another 3 possibilities, 2, 4, and 6. Right? So that is called the complement. So if we added those the event and the complement events, then you can make the sample space again, isn't it? The sum of the probability of the event and the probability of its complement will be 1. So getting odd number is having probability of 0.5, 3/6, right? So not getting an odd number, the probability is again 3/6, 0.5. So the probability add up to 1. 0.5 plus 0.5, it's 1, right? So then the sample space consists of the outcome 1, 2, 3, 4, 5, 6, right? So that is called a complementary event. So another example, when 2 coins are tossed, find the complement of getting all heads. Getting all heads, that is getting H and H, right? So we know the sample space, there are 4 outcomes. Getting both head, that means getting all head, and head and tail, tail and head, and both are tail, getting all tail. So complement of getting all head is the complement is getting all tails? No, the complement should be not getting all heads, right? So the complement of getting all heads is not getting all tails, since the event all heads is HH and the complement of HH is HT, TH, and TT, right? So the complement of event all heads is the event getting at least 1 tail. Or we can say not getting all heads, right? So be careful when you are writing the complementary event, okay? So this is the rule of complementary events. We can write the probability of the complementary event equals to 1 minus the probability of that event occurring. Or we can get it as probability of an event occurring is equals to 1 minus its complement. Or another way, when we add up the probability of an event and the complement of itself, then it should add up to 1. So that is the rule for complementary event. Okay. So these things are very basic things. When you are going to next chapters, it's going to be somewhat complex. So if you have the basic idea, it's easy to handle the course in future, right? So you know the Venn diagrams as well. So the probability values can be represented in pictorially by Venn diagrams. Venn රූප සටහන ඕගොල්ලෝ මම හිතන්නේ ඒ level වලට මේව ඔක්කොම කරලා තියෙන්නේ. So here in Venn diagram, the square is indicated. The probability of sample space occurring in the sample space is denoted using this whole square. This square. And probability of a simple event, if we denote it as E, the probability of a simple event can be denoted using this circle, right? Its probability of E. And the complement is the other part, okay? So the figure A shows the probability of a simple event and figure B shows the probability of complement of that event. Okay. So far we have learned about the classical or theoretical probability. So this is the empirical probability. The second type of probability is empirical probability. Actually, this is also same as the theoretical probability, but here we do the experiment. In theoretical or classical probability, I said that we are not doing the experiment. We are considering that all the outcomes have the equal chance to be selected. But in empirical probability, we do the experiment. It illustrates the likelihood of an event occurring based on the observations. We observe the experiment and then illustrate the probabilities, right? The difference is in classical probability, it assumes the certain outcomes are equal likely to occur, right? Such as outcomes when a die is rolled. We assume that each number has a same chance of getting selected, while empirical probability relies on actual experience to determine the likelihood of outcomes. We are doing the experiment and then through the observation of that experiment, we are defining the probabilities of an event occurring, right? So as in before, in theoretical or classical probability, the equation is somewhat same. Given a frequency distribution, the probability of an event being in given class is given in this equation, frequency of the class divided by total frequency of the distribution. When you are learning the example, I think it's clear. So see this example. A researcher for an automobile association asked 50 people who plan to travel over the holiday how they will get to their destination. The results can be categorized in a frequency distribution as shown, right? So there are three methods of traveling. drive, fly, or train or bus, right? So 50 people, out of 50 people, there is 41 people who travel, drive, and 6 fly, and 3 train or bus, right? Altogether it makes 50 people. So if we find the probabilities separately that a person will travel by car, airplane, and train or bus, the frequency, here it says frequency of the class. So the frequency of first class, the drive class, is 41. And then total frequency of the distribution. The total frequency is 50, right? Total frequency is 50. And frequency of the class drive, it's 41. So the empirical probability can be written as empirical probability of person will travel by car, it is equals to 41 over 50. And by airplane, it's 6 over 50. And train or bus, it's 3 over 50, right? So here the experiment has done, and also there is no anything like equally likely chance to occur, right? By observation only we can know the probabilities. So that is the difference between theoretical or classical probability and the empirical probability, right? So when we are talking about this empirical probability, it's also important to know the law of large numbers, right? Law of large numbers. The law of large numbers tells us that as the number of trials increases, the empirical probability gets closer to the theoretical probability, right? So when the number of trials increases in the empirical probability, it gets closer to the theoretical or the classical or true probability, right? So for an example, let's say if we toss a coin, a fair one, once, it is obvious that probability of getting head is half. We know that if the coin is fair one, then probability of getting head is half, right? But if we repeat the same experiment again and again, several times, say a 50 or more than 50, then we will not get 25 heads most of the time, right? We can't say that 25 is head, 25 is tail. We know that if we toss coins once, we have the probability of having head is half and probability of having tail is half. But if we repeat it 50 times, we cannot say exactly half of the trials having the heads and exactly half of the trials having tails. But as the number of trial increases, the empirical probability of getting head will approach the theoretical probability of half. I think you can see it from this graph. From this graph, see, when the number of trial increases, the proportion of getting head is close to here the 0.5, right? So this concept is called, or this phenomenon is called, the law of large numbers, right? When we increase the number of trials, then the empirical probability gets closer to the theoretical or the classical probability, right? So it is the phenomenon of law of large numbers, okay? Okay. The last type of probability is subjective probability, right? So we learn there are 3 types of probabilities: classical or theoretical probability, then empirical probability, and the final one is subjective probability. So in theoretical probability or the classical probability, any outcome has an equal chance of getting selected, right? But in empirical probability, it doesn't have equal chance. So we do the experiment, and by looking at the observation, then we can decide the probability or calculate the probability. But in subjective probability, it uses the probability value based on an educated guess or estimate, employing opinions and inexact information. We do not have exact information, but by experience or the guess, we obtain the probability. The guess or estimate is based on person's experience and evaluation of a solution, right? From the experience, we are obtaining this subjective probability. For an example, a physician might say that on the basis of her diagnosis, there is a 30% chance the patient will need an operation. There is a 30% of chance. So 0.3 of probability, right? Probability is 0.3. So she has not done any experiment, but from her knowledge or past experiences, she says that there is a 30% of chance the patient will need an operation, right? So that type of probability is called subjective probability. And another example, a seismologist might say there is an 80% of probability that an earthquake will occur in a certain area. So we can't do any experiment there, right? There is no any outcome that we can say that equally likely to happen. So, but based on some studies and also based on some experience, we can say there is this much of probability of that something happen, right? ඔගොල්ලෝ ක්‍රිකට් මැච් බලද්දිත් කියනවා නේද? මෙතන මේ පුටුවේ ඉඳගෙන හිටියාම ඉඳගෙන දිගටම ඉඳගෙන හිටියොත් නම් අද මැච් එක දිනයි නේද? අන්න ඒ වගේ ඔගොල්ලෝ ගෙස් කරලා කියන්නේ එක්ස්පීරියන්ස් වලින්. අන්න ඒ වගේ වට තමයි මේ subjective probability කියන්නේ, right? So these all three types of probabilities are used to solve a variety of problems in business, engineering, and any other fields, right? So there are basically three types of probability: classical, empirical, and subjective. So you can use those three types of probability to get an idea about any event happening or occurring, right? So those are the things I wanted to teach you today as the basic things. So if you have any questions, you can raise your hands and ask, right? If you have any question, you can ask now. You can either unmute your microphone or ask or send me a message, right? I guess there is no any questions since these are the basic things in probability. So then I'll wind up the today's session. So the next lecture you have in Wednesday, I guess, Wednesday 3:30, 5:30. So 3:30, 4:30 you have that lecture, and 4:30, 5:30 you have the tutorial. But since you are not having any tutorial this week, I'm going to take both hours, 3:30 to 5:30, right? So can you explain the graph that given before and right? This one. Wait. Okay, the law of large numbers, isn't it? So in empirical probability, when we increase the number of trials, the empirical probability gets closer to the theoretical probability, right? So when we toss a coin once, a fair one, for an example, getting head is half. We know that according to the theoretical probability, getting head, the probability of getting head is half, right? But when we increase the trials, number of trials, so it is the probability that we toss that coin once, right? But if we increase the number of trials, we can't exactly say half of the outcome events, half of the outcomes, we get the half heads and half tails, right? For an example, if we done the experiment 50 times, we are not getting exact 25 heads and exact 25 tails. නේද? අපි experiment එක කරොත් ආයෙත් අපි 50 සැරයක් කරොත් අපිට 25 සැරයක් හරියටම head හම්බ වෙයිද? 25 සැරයක් හරියටම tail හම්බ වෙයිද? එහෙම කියන්න බෑ අපිට නේද? ඒක වෙනස් වෙන්න පුළුවන්. හැබැයි අපි ඒක තව number of trials ගන්න වැඩි කරොත් 100 200 300 ඒ වගේ trials ගන්න වැඩි කරොත් අපිට පුළුවන් අර empirical probability එක theoretical probability value එකට ළඟා වෙනවා දකින්න. දැන් මේකෙදි ගත්තොත් මේ graph එකකින් කියන්නේ මෙතනදී number of trials තමයි මේ පැත්තට indicate කරන්නේ trials, right? So proportion of getting heads is getting, see here the number of trials are plus, but when we increase the number of trials, the probability of getting head is closer to 0.05. ඒක තමයි අපි classical probability එකේ මෙතන half කියලා ගත්තේ 0.5. එතකොට number of trials වැඩි වෙනකොට classical probability එක empirical probability එක theoretical or the classical probability එකට close වෙනවා. අන්න ඒක තමයි law of large numbers කියලා කියන්නේ. Right? I think now it's clear. Okay. Okay, I'll wind up today's session then. So if you have any problem, you can email me or contact me through WhatsApp. In the first slide, I have given you my email address and the contact. So hope you enjoyed the session. So actually, it is better if I can see you in physically, but unfortunately, due to the COVID situation, I can't see your faces, beautiful faces, isn't it? Huh? So I hope you in near future, I can physically see you, right? Okay. Okay then. Hope you have enjoyed the class. See you. Bye.
Thank you, madam.
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 Okay, you are welcome.
Thank you, madam. Thank you, madam.
Thank you, madam.
Thank you, madam.